All right, so welcome to this after-lunch talk about Kubernetes. I'm trying not to spoil your desserts with YAML just yet. I want to show you some things that are new to .NET, but also I want to explain some Kubernetes to you. The reason is, hi, I'm Martin, and I've recently worked with Kubernetes. So I work for a consultancy in Vienna. The consultancy actually is based in Finland, called Tieto. But over the last years, I've been working more and more with Kubernetes, had to learn a lot of things, some things the hard way, and I want to share a bit of that with you. So to give you an easier way into Kubernetes. So what I'll be doing is giving you some overview over Kubernetes. So maybe if you have not worked with it before, you understand some of the core concepts. And we will be deploying things to a live cluster. So hope the demos will work. So we'll be deploying a .NET app later and spinning it up in a real cluster. Also, I want to talk a bit about how you can package your final applications. In our case, we ship some Helm charts. I'll explain that later to customers. So we package things that customers can install on their own clusters. Why we've been doing that? So we've seen a few different needs. So some customers come to us and say, yeah, we're using Kubernetes. If you want to write software for us, if you want to be paid, you need to ship it in a way that's able to run in Kubernetes. Others want to move to the cloud, but don't want to avoid or want to avoid vendor lock-in. So in at least the German-speaking area, customers are still a bit afraid of the cloud, either for legal reasons, for political reasons, whatever. And so we also see a lot of mix with hybrid environments where people want to run things on premises or in the cloud and want to use kind of basically the same way of packaging the application that works in both instances. And Kubernetes really helps here. Also, we've worked with companies that run their factories that produce goods, and they have on-premise Kubernetes clusters as well. So we've been working with them, and we had a look at, okay, we need to do something with Kubernetes. What are the tools that are available to us? And then once you look up that chart, it's really hard to like navigate all the different concepts and components. So I hope I can give you an easy introduction if you're new to that. One thing is the terminology. So everything is based around shipping things. So we have very nautical terminology. Those of us who've been to the boat yesterday may have used some of them or seen some of them. So we're shipping containers from docks with Docker. And also the name Kubernetes is from the Greek word Kubernetes, which just means pilot or helmsman. And all the other tools you will see will usually have some reference to some nautical terminology. So when we think of shipping an application or making sure that an application runs in production, we usually have some different components involved in there. We usually have some operating system kernel. We have some operating system around the kernel. In Windows, that's usually kind of intertwined. In Linux, it's a bit more open. We have some form of application server. So for example, if we're developing an Angular application, that might just be some Nginx web server, Apache web server, whatever, with our stuff on the top. So usually we write the stuff on the top and then figure out how to deploy the thing into production. And the first time we do this, we usually create an installation document, and that is hopefully up to date 2 years later as well. Yeah, I hate writing documentation. So how does this look when you move to containers? So in containers, we basically package everything that is not the kernel and pack it into one shippable unit. And we only need to take care about that. So we no longer need to explain to operations people how Nginx needs to be configured, where these files need to be placed. It's already pre-built. So that installation document goes away. Yay, I have to write less documentation. I like that. But actually, I do write documentation. It's just, it has become code. It has become the instruction on how to actually build that container. So instead of some PDF with some prose words, we can just write code. All the steps that are needed to generate the container that is then able to run. And the way this works is we basically share the operating system. So traditionally, I don't think anyone still does that, or actually I once worked with public safety infrastructure where that had to be done, just work on bare bones. We usually use some hypervisors, some virtual machines, but we no longer need to manage the virtual machines. We just need to manage containers that run on some shared operating system. By the way, if you're designing such systems, a container is a very good isolation boundary. It is not a security boundary. So you're sharing the kernel, you're sharing resources. If you need to design an architecture, do not consider container boundaries as security boundaries. That's also why you will see, for example, with Windows containers, options like Hyper-V isolation for containers, where they actually spin up a new kernel instance just for your container. But of course, you're writing usually more complex applications, right? If we spend 2 years developing a large system with 20, 30, 40 people, whatever, those applications become quite complex over time. And you need to figure things out, like how do you communicate between containers? How do I do the configuration management? It's usually more than one instance that's running. I'd like to have that work in kind of a resilient way, run across multiple hosts. Then I need to do load balancing. I need to figure out how to configure my different services and so on. Usually, I also want to have zero downtime deployments. So deploying an update and everything should still be running. Traditionally, there might be some problems with that, especially when you're dealing with legacy software that you need to lift and shift into Kubernetes. But at least you get some tools with that. That's basically called orchestration. There were a few other options, but Kubernetes just came along and killed everyone else. So the momentum behind Kubernetes is just enormous. So it's more and more companies publish how they use it. It's more even seen in public companies that used to operate their own data centers. And yeah, no, we're not doing anything new. And that changed over the last 2 or 3 years, even in Austria. And how you benefit is those platforms, orchestration platforms, help you with a lot of the cross-cutting concerns. So when you do some deployments, you do operations, there's things you need to think about, like logging, how you configure your application, how to do deployments, how these things find each other, as well as how you do some diagnostic work if you need to figure out how certain bugs happened and how you reproduce them. And also, there are more things up there, but at least the platform, Kubernetes, can help you with some of them. So for example, you can even have Kubernetes figure out how you reach some other service that you need, but even the things on top of that, so like dealing with different communication protocols or some frameworks that help you implement microservice architectures, those will usually be easier to do once you run on Kubernetes because there are tools and frameworks based on Kubernetes that will help you tackle these as well. And Kubernetes comes in a lot of flavors. So if you Google things, OK, I need to set up a local Kubernetes cluster for development. Maybe we cannot do it in the cloud because of legal reasons. For example, if you're working with some infrastructure provider that works in critical infrastructure, and you look at how this is built, and I think it's built kind of similar to Linux, where you have basically an open source core that you could use on its own, but it's quite difficult to do. So you could download all the components, it's Go source code, you can compile it and you can run it, but it's very difficult to configure. So usually you will use some form of distribution. Can be something like SUSE Rancher Kubernetes engine, can be Red Hat OpenShift, or the OSS variant OKD. And that is usually easier to install on premises. But if you go to the cloud, you will usually use some kind of managed service, like Azure AKS. You can use the Google Kubernetes engine. Amazon has an offering as well. And even on local hosting companies, you will usually have some form of managed Kubernetes platform as well. And speaking of these components, you will usually see 2 types of components. One are the control plane components that do all the intelligent work, and then there's the things that just runs on your worker nodes. So I just wanted to highlight 2 of these in the, OK, that doesn't work. So basically, the thing that you interact with will be the API server. That's what you just interact with when you deploy something, when you ask Kubernetes, hey, what's the status of something? That's the thing you interact with. And then there's a database in it. Basically, I usually explain Kubernetes. It's a database of configuration and things around it that make it work as you configured it. If you use a managed service, usually those control plane services will be managed by the cloud vendor, and you only manage and pay which machines or which worker nodes you need to run. So I would have something like Azure AKS, where I just define, okay, there are certain pools of agents, maybe with different sizes. I can mix and match mix Linux nodes and Windows pools, and just configure how many I want and pay for them. So it's become quite easy to set up Kubernetes in cloud services right now. So how does Kubernetes benefit me? So everything in Kubernetes is basically abstractions or abstractions or abstractions. So you have some application needs that might be networking. So you have two containers that need to talk to each other. You could tell Kubernetes, hey, we want to talk to each other. And whatever your networking infrastructure might be, you could have some on-premise Cisco networking. You could have some Azure VNets that will just work without using an application developer, or most of the times even operations guy need to think about. You can also say, okay, my application needs storage. Like, I need to persist some PDF files that people can upload. And whatever platform you run on, that storage will be provided for you. So you don't need to think about like mounting Azure disks or using elastic block storage. You can just say, yeah, I need this directory to be in persistent storage with maybe a few options, like how fast should it be, how much space to anticipate, etc. Same goes for load balancing. So different clouds have different infrastructure. Different on-premise systems can have different, like Cisco load balancers, for example. You just say, yeah, these instances of this service, that needs to be reachable via the public internet and load balanced, please make that work. And in Azure, if you use AKS, that will, for example, be an Azure load balancer. And there are some other things apart from infrastructure. So you can have some configuration that can be just like key value pairs, or you can have secrets that you would usually use for things like database passwords or default application passwords. Also, don't forget you're running on a platform that implements scheduling. So you can also make use of that and do things like cron jobs in the thing that already implemented scheduling across a distributed system. So don't forget that your platform can also help you with your basic in-app abstractions. So for example, if I had 3 hosts that were a small Kubernetes cluster, I have an application with a web server, some API component maybe, and a database server. What happens if I deploy that? Kubernetes would try to distribute my workloads. And then the Postgres service said, yeah, I also need some persistent storage. So the storage would be provisioned, it would be mounted, and it would make sure, the platform would make sure that this persistent storage is available at the directory that the Postgres expects. And if that host goes offline, that workload will just be rescheduled on a different host. Again, persistent storage is persistent. It's just mounted to another host without any operator intervention. If I then try to scale up my application, maybe have 3 instances of my service running, it would just spin up more services. And if I then wanted to update to a newer version, so the green one up there, the default would be rolling updates, so it would just spin up new instances and kill the old ones continuously. The way we usually split up or divide the cluster is using namespaces. So we can have different virtual clusters or virtual views of clusters to separate our applications. These can be like different applications that need to be deployed on the same cluster. You could also use production and staging environments and make sure that you don't run into any like CPU and memory resource conflicts with that. And you could have 2 instances of the same application running on the cluster. This is also a good boundary to separate like which users have access to which namespaces. So if you're using any access control system, that's also a good way of separating a cluster, especially if you run things like OpenShift over maybe 1,000 nodes on premises. There's usually some access control implemented, so you will have your own virtual view over the namespaces that you have access to. Now, let's look at the different components and deploy something. So the smallest unit in Kubernetes is called a pod. So when you work with tools like Docker, you would create a container, and that would be the smallest instance in Docker. The smallest instance in Kubernetes is basically a pod. So you use a pod to run a container. You can actually also run multiple containers in there. That's usually used for additional things like logging, proxying, etc. But every pod gets its own IP address. It can communicate with other pods, with the other pods' IP addresses. It will have networking setup, and it will have persistent storage setup. So for example, you could have a pod that has a container with a web server and a container with some synchronization service that just synchronizes some local volume. And that would be the smallest thing you can deploy. And how you would do that is by using YAML. So I've set up a small cluster in Azure in Europe, so I hope that works. And the main thing about Kubernetes is it's all YAML files. So much YAML files to become sentient, basically. And you usually have these things that you deploy with some API version and kind. So this is a pod that I want to deploy. A metadata usually specifies the name or the namespace where it goes. In this case, I am in a demo namespace. And then you just define which containers should go in the pod. There are other things as well you can set, but one of the most important things is resources. Now, the important thing is, of course, which image I want to deploy. So I give a name and an image. So for example, I want to deploy the BusyBox image. I can specify some command that needs to run, but I can also specify the resources. And that's important mostly for scheduling. So for example, you say, I need it around, what's 100M? It's a milli CPU, so it's 0.1 CPUs. That should be free on that node so that the scheduler would schedule the workload on that node. You can also specify some limit, so if you use more than that, you can set a higher limit to just allow it to have some more available during peak load. So what I do here, I run a shell command in a BusyBox container that just prints something and then sleeps for 10 seconds. So how do I interact with my cluster? So on the command line, we have kubectl, kubectl usually. For the rest of this demo, I have abbreviated that with KC. So I have more screen estate available. And I can apply this YAML file. I can also use this kc get PO is short for pods command. Now if I'm executing that, it will say, oh, it's running. Perfect. So I've been able to deploy something. But you notice there is a sleep command, so it just finished. And now it's running again. The reason it's doing that is Kubernetes actually figures out, I defined that something should be running. So if it stops, I need to restart it. And that's what it should do whenever it stops or crashes. We can also have a look at the output. Using kubectl logs. And I should see the output of the last run instance. After some time, it should also try to do some backoff. So if the application fails all the time, you will also see the state crash loop backoff. So it will wait a bit until it tries to restart. That can be up to minutes. So let's delete it again and kc delete. Perfect. And abstraction over that, since I don't want to create 500 YAML files if I want to just deploy 50 instances of 10 services. I want to basically have an abstraction over that as well, and that is called deployments. So you don't need to think about the individual pods. You just say, hey, I need to have 3 pods that kind of look like that. So you give it a template, and you specify how many of them you want to have run. And what the abstraction also does is when you do some changes to that configuration, basically you want to deploy an update or a change, that will also take care of things like rolling updates. So you can specify like how many things do you want to have offline at a given time, and it will do that for you. Let's have a look. Let's watch deployments and pods. So that YAML file is a bit larger. So it's no longer a pod, it's a deployment. It also has a name. And then it has a specification. And now it gets a little bit more complicated. So I said a deployment is based on some pod template. So you will see there is a template entry here. And that's basically the same I would have in the pod YAML file. So I have more metadata, and I also have a specification. So you will see spec a lot of times in YAML files, and you just need to mentally keep track of where you are. That's one of the difficult things about these YAML files. In this case, this is now a pod specification, and that should look quite similar to what we have done in the past. We specify which image to run. We specify some resources. And in this case, it's also a web server. And we want to tell Kubernetes, yeah, you know what? This service has something running on port 80 that's interesting. Maybe you want to use that later on somewhere else. We could also use this to define some aliases, but this is standard HTTP that works with all the defaults in the platform. So what's this? This is, we are able to specify some additional metadata on basically everything, one of them being labels. I can apply labels to pods, I can apply labels to deployments, and that's used to find things later on. In this case, a deployment is basically a reconciliation loop. So every so often the system will look at, okay, which pods are running, which deployments exist, and then it says, okay, there is a deployment that says I want to have 2 instances running with a selector that says I want to have 2 instances running matching this definition. And if it doesn't find 2 of them, it will deploy them using this template. So that's the way to think about these selector definitions. So selectors are usually used to find pods, and then the reconciliation loop will see, okay, what do I need to change in the system? And that's basically how most of the things in Kubernetes work. So let me just deploy that one. And we see we have this deployment now. It says ready 2 of 2. And we can see there are 2 pods in here. Those also get some random name. So we have 2 distinct pods, and they should be running. So what happens if I do some changes? Let's maybe change that to 3. So it just spun up another instance. If we lift and shift existing things to Kubernetes, sometimes we're not able to have rolling updates working, especially with database updates. Sometimes you need to do something different. If you really, really need that, there is a way to do that using a different deployment strategy. So you can change that, for example, to recreate. So if I deploy a new instance, if I change the image, there's a newer version of Alpine available. It would restart all the containers at once, so your system would be offline. Yeah, now it doesn't find the image because I think 23 should be the next one. So you see there is an error image pool. And now let's change back to the default configuration. So the default should be rolling updates. You see there are now 4 instances scheduled. So there are containers where containers creating while others were terminating. So we had now a rolling deployment. Yeah, I just deployed an HTTP server. How to reach that? One of them would be to use port forwards. So for example, if I use this VS Code Kubernetes plugin, I can see there's deployment, there are the pods, and I can actually set up a port forward. Maybe local port 8080 to one of the ports of that deployment to port 80. So there's the kubectl port forward command. I don't like to type that manually. So let's see, localhost. It works perfect. So next to deployments, there's also a different way to deploy pods. That would be StatefulSets. So you've seen these pods have some random identifier. There are situations where you don't want that. Usually these will be stateful applications like databases or cache clusters. And they really rely on some stable naming. So for example, cache instance 1, cache instance 2, cache instance 3. And because when you deploy new pods, the cluster usually needs to know, hey, did node 0 recover again, or did I add a new node to the cluster? And so this is usually fixed by using StatefulSets. Those also do not do rolling updates. They just restart one instance after another, in contrast to the deployment, where we just see they just restarted everything at once. And usually they also have some additional methods to have different persistent storage for each instance. But typically, you would only see that in like pre-existing software that you deploy to your clusters that is like a database or a cache or something else. But what you will need is then a way for these services to talk to one another. So I could find out which pods are running, what IPs they have in the cluster, and talk to them by IP address if I run some containers. But finding these IP addresses is kind of hard. And that's what services are for. So in Kubernetes, your typical way of resolving other services would be DNS. And services help you set up the DNS. So you can provide a single endpoint for things to connect to the instances of your pods. There are a few different types. The default one is cluster IP. So every service could have one IP address that you just use, so you don't need to think about something like making sure that you do DNS queries all the time and you don't end up with stale DNS entries. So you just have one IP, and that IP will be load balanced to some instances of the application that are running. So that makes it a bit easier to think about these ways of resolving other things. So if you also want to make things available outside of the cluster, you can also use services for that. So you can, for example, deploy a node port service that will still have an internal IP, but for example, it will make the service available on all the worker nodes on a specific pod. So for example, if you're deploying on-premise systems, you maybe have some AMQT or MQTT messaging system. You can just say, hey, expose port something on all nodes and forward it to that instance, and that would work quite well. In a cloud environment, you would usually use a load balancer service. If you want to make things available to the public, that would usually provision a new IP address or configure an existing load balancer to also have some rules to balance to your instances. So let's try and deploy some services. So, service, again, kind service, some metadata with a name. This, for this one, I want to deploy a cluster IP service, which it's basically the default. And again, I specify a selector. So I say, okay, which pods do I want to target? Again, with these labels that I want to query, and what ports do I want to expose? So you see there is a new service created. It has a new different new IP address. And now every component in the cluster could just use this IP address to talk to our services or resolve it via DNS. So just to test that, I have some pod that runs a BusyBox instance. So, and a good way of now running things in the cluster is I can just execute something in an existing container. So I want to have an interactive terminal to my BusyBox container, and I want to run a shell. Perfect. So I could do curl HTTP. This IP address. Curl doesn't work in here. Then use wget. And I get this Nginx HTML page. But of course, I hate IP addresses. So I can just use the name of the service. And that should work. If you deploy things in different namespaces, the full name would be demofrontend.demo. That's the current namespace name. If you need to talk to things in different namespaces, you can use the other DNS components for that. In theory, the full DNS is .svc cluster local, but your default search domains should resolve everything fine with service name .namespace. Okay, so let's try something else. Let's say I want to make this publicly available. So I can deploy another service. This time I switched cluster IP to load balancer. So you see load balancer and then external IP pending. And what pending means is in Azure, it will provision a new IP address and configure Azure Load Balancer for that. So I got some IP address. Now let me check that. Maybe not yet. It takes a bit. So in Azure, we usually have that fancy interface. So like here is a Kubernetes cluster, you can change things. In the background, this will actually create a new resource group with all the things in there. So my node pools will become virtual machine scale sets. And in there, I should also see public IP addresses and the load balancer. So by just deploying some YAML file, Azure knows, or AKS knows, how to do that with the Azure Load Balancer and the Azure way of implementing infrastructure. I could use exactly the same YAML file, deploy it to Amazon. It would work the same, just with the different platform components. So I should see front-end IP configurations and the inbound rules. So, yep, now it works. I have my web server. However, that might not be the easiest way to manage exposing HTTP-based services. There's also an abstraction called ingresses. And ingresses you use to define how HTTP cluster from outside HTTP traffic from outside the cluster is routed to components running in the cluster. So it is basically a layer 7 load balancer, actually a reverse proxy. And the way you use it is you say on this host name, maybe with that path, routed to a specific service. And this is the first one that Kubernetes actually doesn't implement itself. So you need to bring your own component that then implements that abstraction. So I could install Nginx, I could install AJ proxy, Traffic, etc. There are some custom plugins as well if you need to integrate maybe an external thing like a physical load balancer that could also integrate with that abstraction. So again, that's the interface you use an application developer, specify what URL, what path goes to which service, and then in turn it will route to the correct ports. You could also do some advanced stuff with that, so like canary deployments, specifying which traffic for which users should go where. URL rewriting is quite good if you have like subpaths, but your application doesn't understand subpaths. You can just rewrite that. And one of the most important things is usually TLS offloading. So you would configure your TLS certificate on the Ingress, or you have a component that creates TLS certificates for you using things like Let's Encrypt. But you can also specify course headers in there, which is quite useful. And you could even do some authentication stuff, like make sure that, for example, there should be a bearer token in every request to your API. So let's have a look at that. So ingresses, next type of record, metadata, and the specification. What recently changed in Kubernetes over the last years is you should specify an Ingress class that should be available in your cluster. Usually when you deploy all these things that you could use to actually do the reverse proxying, they will provide an Ingress class name that you can use in your Ingress definitions. So for example, I want to work with the Nginx system that I already deployed to the cluster, and I just define some rules. For example, demo cluster does multi-AT. Everything under root should go to the service I just deployed at port 80. So currently, there should be nothing running on there, so I'm reaching the Ingress controller, basically the Nginx instance that is looking at the ingresses in the cluster, but it doesn't find anything. So if I deploy this Ingress, yep, that is deployed. It should find the correct Nginx instance. What I can also do in there, it's currently cached in a weird way, is also specify TLS configuration. So once you specify TLS, it will look at some secrets that is also a Kubernetes object that can contain either unstructured key value pairs or TLS certificates and find the correct certificate for the host names. In my case, I also use a component called Cert Manager that I already deployed and configured in the cluster that uses Let's Encrypt to create these certificates. So another thing I can have in that metadata, apart from labels, are annotations, which is basically additional information for other components looking at that definition. So I can tell Cert Manager, yeah, I gave you this certificate issue configuration that's valid for a whole cluster for Let's Encrypt. Just use that, and if this secret doesn't exist, request a certificate. And that's also why this HTTPS is already working. So something I will show you in a bit, you can also have config map secrets. You can also have YAML files for defining how you want to do storage, what kind of persistent volumes you want to have. And what's also quite useful in a lot of enterprise applications, you can run jobs. So you can do something like batch processing, where you can use the API service to schedule a job. Maybe if someone clicks an export button and you need to maybe generate an export, you can write code that actually submits the correct YAML file, or the correct definition, to have your job running maybe for that one export. You can also define cron jobs. So for example, if I want to generate some reports or remove some stale data every hour, I could also make use of that platform. Again, cron jobs, just an abstraction over jobs. So let's have a look at an actual application. So I created a Angular frontend and .NET backend application. I'm going to spare you the details, just saying the frontend is built using a Docker file. You may have done it before. Backend application actually is now written in .NET 7. And .NET 7 will have a new feature for publishing containers. So what you can do in .NET 7 is you can use a publish profile called default container. You specify which operating system and architecture you want to run on, and it will just create that container for you. So, and it actually doesn't use a Docker file. It just uses an API to communicate with Docker to just say, okay, these layers are the base layers. Just add those files that I just created. So you don't need to go through a Docker-based build to get your container. Yep, and it now published this image. I could also specify something like 301. And it would publish the same thing with a different version. So if you have trouble maintaining Docker files to do your .NET builds, this is probably going to help you. I think you can even do it with console applications, and it's not directly. Okay, yeah, it's brought in this case by the SDK. Depending on what type of project you use, you might need to reference a specific NuGet package. You will find that in the .NET documentation, once .NET 7 is released, there have been a few changes to that. Okay. Let's deploy something. I'm just switching namespaces. Nope. Okay, now there are more things in here. Let's just start with a few things already. So in this case, I need a database. This is a bit much to deploy at once, so of course I can use the same file for multiple YAML files. In this case, I deployed a secret. This is basically also deploying key value pairs of names and values. In this case, they are base 64 encoded. I also define a persistent volume claim. That means, hey, I want some persistent volume to be available. Saying, yeah, I want 1 gigabyte, and then Azure has this storage class, which gives me faster Azure disks, and a deployment that references the secret to define an environment variable. So you can define environment variables referencing secrets, contract maps, or just putting values in inline. And it also mounts the volume, or it makes the persistent volume available to the pod and tells the container where to mount it inside the container. So this should be deploying a Postgres database. It should be ready by now. I want to have my front end running. I've also created a service for that front end. It looks just the same as the ones I showed you before. Backend is a bit different. In this case, I'm using ASP.NET configuration system, and maybe I don't want to hardcode all the values either in the application or in the deployment. So I can use something called a config map that also stores key value pairs. In this case, will be making that available via environment variables. And what you need to do in Kubernetes is you need to use double underscores, and the ASP.NET configuration system will understand these double underscores as well. It's just Kubernetes doesn't allow single underscores in environment variables. So deploy the configuration. Now do the deployment. So here I define the container. I'm referencing my custom image. And I'm setting environment variables. So I'm setting some inline. And then I'm also telling it, hey, just everything that's defined in that config map, just dump it into the environment variables. So that's a very lazy way to do things, but it works. So I also want a service for that. And now the important part, I want to have an ingress. So different to what I've done before is, yes, I still want everything under the slash path to go to my front end, but everything under slash API, I want to send to my backend. So I don't need to worry about cores having like a different domain. It's just on the same domain. The reverse proxy will just sort out which requests to send to which basically service. So let's see, that should be running. Okay. The persistent volume was still there. Now let's log in. Luckily, the password is written here. And I should be able to create new items. Perfect. So now I have a running application. How do I deploy that? So we've had a lot of YAML files so far. I needed to deploy, 6 YAML files to just get a small application running. And the more complex your application gets, the more YAML files you have. You're just throwing YAML files together until they're sentient. And the way Helm works is you define a chart, basically a map, the things you want to have in the application in a bit of again, another layer of abstraction. So it's basically a template on how to create those objects. So if I want to have an application, I can package it as a Helm chart and say, hey, these are the knobs you can turn. Those are the config values that we support. And then you render out all these definitions. So these are Go templates. It's a template coding language that might be a bit weird the first time if you have not yet used Go. You usually define a default values file, which is also just a YAML file that with your own schema. And you allow users to customize some of these values. So you will have an override that is just merged. And then you can use your template to use the values in there to render your definitions. Also, when you've done that, you can package that. You can ship that to registries. You can let other people use that. And you can even use pre-built Helm charts. So just a quick demo. How would that look if I actually use Helm charts? So for example, let's say I want to install WordPress on my server. That would mean I could add a repository. In this case, Bitnami is a company that publishes a lot of Helm charts. I can update the things that are in there, so it just knows, it downloads the index and knows which packages there are. I've already done that, so that would be an error now. Yeah, and now have the WordPress namespace. Now I want to not use the default password since it will be available publicly. So I've created a secret definition. And the way many Helm charts work is you can define values, And you could define values inline, but that means they're no longer in this secret system where it might be encrypted in the backend. So usually reference existing stuff as well in Helm charts. So in this case, these are some config values that I can change in the Helm chart. So I can change something like the username. I can change service types. I can enable ingresses and define the things I will specify about these ingresses. So I want to have TLS. I need this specific annotation for Cert Manager to issue the correct certificate and the host name. And the way to install that is to use Helm install with a release name, which chart to use, which namespace to use, and my override values. So it's now slowly coming up. It deployed a database that might take a few seconds to spin up. So there's just a lot of things going on there. Still creating. I can also have a look at that via some UIs. So for example, I like to use Rancher, which can actually manage or connect to multiple clusters. Have a look at the workloads in the WordPress namespace. Perfect, so things are deploying. And I can also look at storage, so there should now be persistent volumes in here. So something for the MariaDB, created 50 seconds ago. Yay, the database seems to be running. Now WordPress should be starting in a moment. Yep. And here we are. So that's successfully deployed. I'm not going to log in now. I hope you trust me that that kind of works. But usually you want to create your own Helm charts. So you can use commands like helm create foo, which would create a new, basically empty chart. There's already a lot of the structure you will need in there. So for example, your default YAMLs file, some templates that will help you set up sensible defaults. So for example, like a deployment, and then there's a lot of templating thing going on in there. I've already created that for the to-do list. Already exists. So in my to-do list demo, I also have this values file, maybe some different defaults, and my own template. So for example, in the Ingress there, I can use some variables so that the language is a bit more complex. I suggest looking at some examples, looking at some in GitHub, and looking at the documentation. You will find a lot of things like these include statements or template statements. Use things of a template file. You can also have some logic there, like if, else, if I specified an override value to something with that, or it just, yeah, play with it a little. That's the most I can say in the remaining 10 minutes. But it usually makes it easier to make things configurable. So whenever you want to specify some concrete value in the YAML file, you would usually reference the values that have been provided to the Helm release. So let's just try to deploy that. Helm install, test instance. Then I need to specify the Helm chart. That's now just a directory, to-do list, and I have some override values here, and that should deploy a different instance. All right. So I'm not going to wait for that to be fully deployed. Let's just have a look at some other things. So I already mentioned, if you're configuring with .NET, environment variables work by default. You can use double underscores to set them. You can also mount things as files. So if you have config maps or secrets, if they're JSON formatted, it's very easy to just mount them as files. So you can mount not just persistent volumes, but also you can use your secret as a volume, reference the JSON file in the configuration builder. With database migrations, I usually suggest trying to deploy as often as you can and make sure your deployments are backwards and forwards compatible. It doesn't work all the time. Maybe you need to fall back to this recreate deployment strategy. Or you have something like an init container that blocks the startup of your new pods until the migration is done. And then as part of your deployment, you can deploy a job that will perform the migration. So your rolling update would wait on that migration to be performed by a job that you schedule, and then those init containers will unblock the further starting of all the new pods. So you can also do that via Helm hooks. So if you use Helm upgrade, that will automatically schedule that job for you. Yeah, if you use Helm wait, it would try to wait for all the pods to start up for scheduling the job. You do not want that in that instance. Yeah, that's how you configure a Helm hook. You just set some annotations. Helm will recognize these. So the way I did this, I have an init container in every important pod that needs a database that just runs some tool image with the command wait for the database. Also a tip from my side, implement consistent versioning. Make sure that your pipeline runs have the same version as your containers, as your Helm chart. I really like to use nerdman git versioning here. It's a tool called .NET NBGV that just makes some environment variables available based on the Git history. And then I can just update Helm charts, publish them, etc. Also note you can use Kubernetes in your application as well. So those pods will usually be scheduled using a service account, and you can give this service account rights to do something like read configuration, schedule jobs, update deployments. And you can use the Kubernetes client NuGet package to actually do that. So the way this works is you can, at some point, specify a service account and make sure that this service account makes the token available to each container. You define some rights on some specific APIs using roles and role bindings. Yeah, it's a topic that could fill an hour as well. And then in your .NET code, you can use HTTP clients, typed HTTP clients using the HTTP client factory to create new Kubernetes client instances. And in this case, we were writing some implementing partitioning for a service where we found out, yeah, we have some problems with the cap theorem. Let's work around that. So we were watching all the other services that were started and figure out which requests to send to which individual pod. So we are using services to resolve all the instances that are running behind the service. But you can do much more. Some other things you can look into, autoscaling. You can do that via something called horizontal pod autoscaler, which is a very dumb thing that just looks at high CPU usage, or event-driven autoscaling, things that would look at like your queue length. You can also use service meshes that help you with securing communications between services, and also having some policies to say which thing can talk to which other thing. Again, monitoring tracing tools. There are two great projects. One is Dapper, Distributed Application Runtime, that helps you, that also gives you more abstractions you can use in distributed applications. Also, if you don't like to create YAML files while developing something, there's Project Thai. That's basically like a compose file for Kubernetes. And one more topic you can also explore. You're already running in a system that is basically a database. Maybe you want to use your own resource type. So things like deployment, service, etc. I could have like machine configuration. and I would no longer have to implement something like a config system for that. I could just load machine configurations via the Kubernetes API that works. I once specify a schema, tell Kubernetes, hey, expect objects with that schema, and then I could write an operator that basically looks at these definitions and does something based on that. Maybe schedule instances of deployments or do some configuration changes based on that. And that would work with all the UIs. So it would show up in, for example, that Reggie UI I showed you. And you could use that, for example, as a configuration interface. So since there is no time left for questions, just talk to me and have fun at the conference. Thank you.